Hello everyone. We are still on the journey of doing the May-June Mathematics Paper 1 memorandum. Today I'm going to cover functions. So I'll focus on question 4, 5 and 6. Okay, on the first question in question 4. Okay, here we're given g of x. Oops. Okay, this graph is a hyperbolic function. Okay, let's answer the questions. 4.1. They said to us, write down the equation of the asymptotes of g. Okay, I have both horizontal and vertical asymptote all together. For my vertical asymptotes, I know that x is equal to 1. And for my horizontal asymptote, y is equal to positive 2. Then 4.2. For 4.2, I'm asked to draw the graph of g indicating the intercept with the x's and the asymptotes. Okay, so for me to draw the graph, I must first calculate the x and y intercepts. Okay, for my because I already have the asymptotes, so the only things that I must find for me to draw a complete graph are both the x and y intercepts. For my x intercept, I don't care what graph it is, whether it's a trig graph, cubic function, hyperbola, parabola, exponential. Whenever they say to you calculate the x intercept, just make y 0 and solve for x. So in our case, y will be 0, and then we must solve for x. We'll have 1 over x minus 1 plus 2. And then for us to solve x, in this case, whenever we have fractions, we must multiply everything by LCD. But for now, we must, to make it more simple, let's just take 2 to the other side, and then multiply everything by LCD, or in this case, you can just cross multiply. We'll have 2x minus 1 is equal to 1. This is equal to negative 2x plus 2. Negative 2x is equal to negative 1. Then x is 1 over 2. That's my x-intercept. And then I must find my y-intercept as well. For my y-intercept, I need to make x to be equal to 0, then solve y. I know that y is equal to, let me just say, since I'm going to put 0 langbona on x, I must just say g of 0. Whenever I see x, I put 0, then I solve for y. This thing will give me negative 1 plus 2, which 2 minus 1 is 1. So for me to draw my function, it will be much more simple now, because I do have the asymptotes and my intercepts. My function will be like this. My asymptotes, let me draw them in green. I know that x is 1, so here x is 1, y is 2. Okay, since the value of a is 1, the value of a is this number here, the numerator of our fraction, and 1 is a positive number. So since the value of a is positive, this thing simply means that our graph will be on the first and third quadrant of the asymptotes. So the shape of our graph will just go like this, from one asymptote to the other, from one asymptote to the other. I know that here my y-intercept is 1, my x is a half, y 0, x-axis. Please don't forget to always label your x's. So that's my hyperbola. Okay, and then 4.3, I'm asked to determine the values of x for which the graph of g will be positive. Okay, the graph represents the y. Are you together? So whenever y is positive, it simply means my graph is also positive. And I know that y is always positive above the x-axis. Are you together? So whenever my graph is above the x-axis, I know that my graph is positive since y is positive there. So whenever I look here, my graph will be positive. I hope you're a little bit visible. When you move from positive half going to the left, my graph will be positive. Are we together? And here, after the asymptote, my graph will be always above the x-axis. So to answer this question, I'll just say 4.3 x should be less than 1 over 2, or x should be greater than 1. Because I know whenever x is less than 1 over 2, from 1 over 2 to the left, my graph will be always above the asymptotes. And whenever x is greater than 1, my graph will be always above the x-axis, rather, not asymptotes, the x-axis. Then 4.4, determine the axis of symmetry. The axis of symmetry of G that has a negative gradient. This is simple. For the axis of symmetry, you must always have your graph. Your axis of symmetry is a straight line graph now. Since they said our graph has a negative gradient, so it simply means that the axis of symmetry will move like this. It will pass the point of intersection of our asymptotes. Are you together? For axis of symmetry, whenever on the hyperbolic function, please note that the gradient is always 1 or negative 1. You don't have to calculate the gradient. When they tell you that write the equation of symmetry that is a negative gradient, this is your gradient. Whenever they tell you write the axis of symmetry that is a positive gradient, this is your gradient. Are you together? So therefore, I'll just say y is equal to negative x plus c. The only thing that I'm left with to find the complete equation is the constant value, the y-intercept. But I can just substitute any point on the graph. In this case, I know a point where the two asymptotes meet, and they meet whenever y is 2 and x is 1. So therefore, the value of c is 3. So y is equal to negative x plus 3. Now let's move to question 4. What just happened now? Okay, it's fine. Let's start on a new one. It's a new question. Question 4. No, it's question 5 rather. Question 5. Mm. 5.1. Okay, in the diagram, the graph of f is equal to the log of x base a and g are drawn. G is the reflection of f in the line y is equal to x. The graph of f passes through the point P, okay, Q is the x-intercept of f and r is the y-intercept of y. Okay, whenever they tell us that a graph is a reflection on this line when y is equal to x, they are telling us which g of x is the inverse function of f. Right, together, because only an inverse function is reflected along the line y is equal to x. So here, when they say 5.1, write down the coordinates of P, the image of P. Okay. So since I know that since P is a point on f of x, that means the image of P will be the inverse of the coordinates of P. I just need to swap x and y. So this will be 2 and this will be 4, because they said it's a reflection across the line y is equal to x. That means you just need to interchange the two. 5.2, show that a is 2. Okay, we're given excuse me, we're given an equation like this. Okay, they want us to find the value of a. A is the base of this logarithm. What do we have? We have a point on the graph. I know that y is 2 only when x is equal to 4. For me to solve for a here, I just need to remove this logarithm. And how can I do so? Just need to take the a to the other side, and then these two become the exponent. Then I'll have 4. Then I'll put square roots both sides. Then a will be plus or minus 2. But for logarithms, guys, this thing here can never be negative, because when it's negative, your equation will be undefined. Are you together? So therefore, a is a positive 2. A is a positive 2. Write down the equation of G in the form of y is equal to 5.3. You can just say this thing is 2 to the power x, né? But how did we get there? We know that f of x is equal to log of 2 and x here, né? But now they told us that g of x, we get it by reflecting the graph of f on this line. So this thing simply means that we must just interchange x and y. So whenever I see y, I'll put x, and whenever I see x, I'll put y. So my equation, they want it in the form of y is equal to. So for me to remove the logarithm, I just need to put this base here to be here, and then the number that's on the left hand side will become the exponent. Then I'll have this. But you don't have to do this, guys. I'm just showing you how to get here, because since it's only 1 mark, they'll just mark you here if ever just write the equation. And then 5.4, we are told that T is the point on f of x in the first quadrant, where TR is parallel to the x-axis. So T is a point here. Okay. So T is a point that is there. We are told that it's parallel to the x-axis. So it simply means that R and T both have the same y coordinate. Are you together? The y-intercept for R is 1. We just need to find the x coordinate, né? But remember that t is on the graph of f. Are we together, guys? T is on the graph of f, and this is the equation of f. I know the value of y is 1. I just need to find x. For me to remove the logarithm here, just say 2 to the power 1 is equal to x. So I know that the coordinates of t are 2 and 1. So I'll just write here a 2. Okay. Calculate the area of triangle RT and the image of P. Please guys remember that the image of P, its coordinates is 2 and 4. It's 2 and 4. That means P and the image of T, rather T and the image of P, they have the same x value, like this. So the image of P will be 2 and 4. Since these two lines are on the same vertical line, that means they share the same y value, right, together. So that means here it will be 90 degrees, and a triangle will be, let me just draw it with a different color. This will be a complete triangle. So for us to find the area of a triangle, we need to find the length of the base, which is RT. RT, it will be 2 minus 0, because for a horizontal line, you just need to subtract the x values, since the y values are the same. And then for the vertical distance, or the height, which is t and the image of P, it should be 4 minus 1, which is 3 units. Are you together? So therefore, the area of triangle RT and the image of P, it will be half the base times height. In this case, our base is RT and our height will be T and the image of P. Just substitute this thing since we have them. RT is 2 and then the height is 3. So the area is 3 units squared. That's how we do question 5. I hope you understand. Now let's move to question 6, the last part of the functions. We have two graphs there. We have a quadratic function and a linear function. Question 6. Question 6. 6.1. Okay. But the graph of f and the graph of g are drawn below. D and E are the x-intercepts and P is the y-intercept. The turning point of f is T and y is negative. Okay. The turning point. Okay. The graph of f and g intersect at P and E. Okay. First question, write down the range. For your range, you just need to check where is your graph visible according to y. So I know that my graph will be greater or equal to my minimum point. Right, together. This is how you write your range. Others who prefer to write it like this, y is an element of -4 to infinity, it's still fine. 6.2, calculate the coordinates of D and E. D and E are the x-intercepts, and I said previously, whenever you calculate x-intercepts, I don't care which graph is that one, just know that the y is 0. So for my x-intercept, I need to make y 0, solve x. So I'll say x squared minus 2x minus 3 is equal to 0. Here I just need to factorize. When I factorize, I'll just say the factors. I just want the factors of 3. That when I subtract will give me 2. Those are 3 and 1. Minus and plus. The bigger factor will take the sign of the middle term. So I'll have x is equal to 3 or x is equal to -1. So since E is on the right hand side of the y-axis, it means E has the coordinates of 3 and 0, and therefore D will have -1 and 0. Okay, 6.3, determine the equation of G. Okay, G of x is a graph like this, mx plus c, a straight line graph. I already know that G and F have the same y-intercept, so it will be -3 here. All I need to find is the gradient. I don't have to calculate it because I have a point on the graph which I can substitute. I know that y is 0 whenever x is +3. I took the coordinates of E because E is on the graph of G as well. And when I take 3 to the other side, it will become positive. Then I'll be left with 3m. Divide both sides by 3. Therefore, the equation of G will be equal to x minus 3. Here, when I divide, my gradient will be equal to 1. So that's why here is 1. Then 6.4. 6.4, I'm told to write down the values of x for which f minus g is greater than 0. So you can just do this if you come across a situation like this. For each values of x is f of x greater than g of x. In simple English, they are saying for which values of x is the quadratic function above the linear function. If you check from here, moving to the left, the quadratic function is above the linear function. And if you check from here, moving to the right, the quadratic function is above the linear function. So to answer this question, I'll just say when x is less than 0 or when x is greater than 3. Others may prefer to write it like this. Let me write in orange. X is an element of -infinity and 0 or 3 until infinity. Choose your poison. Which one do you prefer? It's up to you. And then move to 6.5. 6.5, I'm asked to determine the vertical distance between H and G. If G is the reflection of F on the x-axis. Okay. Now since they said h is minus f, it simply means that this graph was turned upside down. Now it's like this. This thing will be h of x. Are you together? So I need to find the vertical distance between this new graph, the reflected graph, and the linear function. I want the maximum distance. So what must I do? Firstly, I need to find the equation of h of x. I'm told that it's equal to negative f of x. So that means my equation will be negative x squared minus 2x minus 3, which is negative x squared plus 2x plus 3. So this will give me the equation of h. So for me to find the maximum distance, I need to subtract the two graphs. And my distance, let's distance be equal to d of x. So I'll just say my d of x is the top graph, h of x, minus the bottom graph. H of x, we just found it to be negative x squared plus 2x and 3, ne? G of x was equal to x minus 3. So this is minus x squared plus 2x and 3 minus x plus 3. Still write d of x. Our distance, any distance on between these two graphs will be given by this equation, yeah? Minus x squared plus x minus 6. Since they said maximum distance, determine the maximum distance. Okay, that means we must derive, because we can only find the maximum distance whenever we derive and equate to 0. So d prime of x will be equal to negative 2x plus 1. For maximum distance, I know that my derivative should be equal to 0. So I will like d negative 2x plus 1 is 0. Negative 2x is equal to negative 1. Then x is 1 over 2. So I know that when x is 1 over 2, I will get my maximum distance. And this equation here is the one that can give me the vertical distance between the two graphs anywhere on the Cartesian plane. And so now I know that my maximum distance, let me write in green, I will get it when x is a half. So I'll just substitute 1 over 2 whenever I see x. And I will get negative, is it negative? Yeah, I'll get negative 23 over 4. Okay, and then for the last one 6.6, I'm asked to calculate what? Given that k of x is that, determine the values of n if k is a tangent. K of x is equal to g of x minus n. Okay, I know the equation of g of x. I just found it before. So this thing simply means that k of x is equal to this. So here guys, whenever they tell us that a graph is a tangent, it means that the graph must touch once here, like this. So here, but determine the values of n if k is a tangent to f. For us to find the values of n, we must first find the equation of the intersection between the two functions, and then make delta for the intersection to be equal to 0. How can you find the intersection? We'll say f of x is equal to k of x. Our f of x is x squared minus 2x minus 3 is equal to x minus 3 minus n. So in this case, I'll just put everything on the left hand side and 0 on the right hand side, basically putting everything on standard form. I'll have negative 3x plus n is equal to 0. This is the equation of the intersection. Since the two graphs must touch, it simply means that delta for the intersection should be equal to 0. And I know that delta is equal to what? B squared minus 4ac. So the value of a is the coefficient of x squared, which is 1, b the coefficient of x, which is negative 3, c is the constant term, which is n. So delta, which is equal to 0, is the same as doing this, and I know this is negative 3 squared minus 4 ac. This will give me 9. This will give me negative 4n is equal to 0. So 9 is equal to 4n. Divide both sides by 4. Therefore n is equal to 9 over 4. That's your answer. If you want to understand this thing simply means that for us to have a tangent, we must move the graph of g 9 over 4 units down. I hope you guys understand and this video makes sense. Please subscribe, tell others to come and join us, change your perspective towards mathematics and physical science.